To plot a number on a complex plane, the x-axis is the real part of the plane and the y-axis is the imaginary part. So if I was going to plot this, it would be 3 in the real direction, 2 in the imaginary direction, and this is where I would plot it. Well, just like vectors, I can find different things. I can figure out the angle. The angle is going to be the inverse tangent of 2 over 3. And when I approximate that, I get approximately 33.7 degrees. So this angle right here is 33.7. I can also find the distance of that radius. And to find the distance, I'm going to take the square root of the x squared plus the y squared. So that's 9 plus 4, which is the square root of 13. So this distance is the square root of 13. All right, let's go ahead and plot the next one. Negative 4i. It's the same thing as saying 0 plus negative 4i. So when I plot that, this would be my number in the complex plane. Well, what is this angle? Well, that's a 270-degree angle with a distance of 4. Finding the trig form of the complex number, I need to find, first of all, the radius. So remember, if I was going to plot this, this is 2, 2. I need to figure out what is that radius. Well, it's the square root of x squared plus y squared, which equals the square root of 4 plus 4, which equals the square root of 8. And 8 can be simplified down to 2 rad 2. The next piece is I need to find theta. Well, to find that, I'm going to take the inverse tangent of the y over the x. So the inverse tangent of negative 1 of 1 equals a 45-degree angle, or pi force. All right, so to find the trig form of the number, it's going to be 2 rad 2 cosine of pi force plus I sine of pi force. There's my solution. Well, if I wanted to check my solution, I can just show you how to check it. Well, pi over 4 is rad 2 over 2 comma rad 2 over 2. So if I took 2 rad 2 times rad 2 over 2 plus I rad 2 over 2, and I did some multiplication, this would give me the square root of 4 plus I square root of 4, which is 2 plus 2I, which gives me the original point right here of 2 plus 2I.